Welcome to Lesson 8.1, Managing the Software Development Lifecycle. In your Candidate Information Bulletin, we are in the Software and Development Security domain. We are in Key Area of Knowledge A, which is Understand and Apply Security in the Software Development Lifecycle. Our lesson topics are going to include the Software Development Lifecycle, the importance of secure software, the Microsoft Security Development Lifecycle, the SDL phases, post-software release maintenance, security updates, and end of life. The Software Development Lifecycle, known as SDLC, is a framework that defines the tasks performed at each step in a software development process. ISO 12207 is the international standard for the software lifecycle process. Now, the traditional software development lifecycle, SDLC, starts with project initiation. Its next stage is functional design. We then move into system design. Then we start actually designing the software. That's the software development phase. Moving into deployment, use and maintenance, and then end of life. So this is a very traditional lifecycle. There are a number of different models that can be implemented in this lifecycle, and in a subsequent lesson we're going to be looking at those models. But the traditional software development lifecycle was not designed with security in mind. It was designed to meet the requirements of functionality and performance. A significant percentage of security incidents are a direct result of flawed software. So secure software is really, really important. And if we look through this graphic, you can see where the problems arise. Right? We start with insecure software being published. So then we have vulnerabilities that are identified, and you can see now we're in the red zone. So once vulnerabilities are identified, we now get exploit code being developed, and now we've got this very vulnerable window, at which point also, or maybe in concert with, the vendor is developing and releasing a patch. That patch then needs to be deployed. So depending upon the deployment cycle, again, we may have a window of exposure, but users and organizations deploy the update. And then lo and behold, the next round of vulnerabilities are being identified, and we get in this constant cycle of vulnerabilities identified, exploit code developed, the vendor releasing a patch, users deploying the update. And this happens over and over and over again. And it happens because we have insecure software that's been published. So if way back at the beginning here, if we can affect this process and have software released with as few flaws and as few vulnerabilities as possible, we can strengthen the entire security infrastructure. Retrofitting existing software is expensive, and it can be reputation damaging. So the traditional security plea for software developers is so please, please, please consider security during each phase, conduct code reviews throughout the process, don't let development teams test their own work, require regression testing for new features and for fixes. So these are the requests that are asked over and over again of the development team. So in response to software development issues, Microsoft developed the Security Development Lifecycle, it's known as the Microsoft SDL, added a number of new steps, starting with training and ending with response, which are both new, and then really focused on ensuring that security is integrated in every phase of the process. So we're going to go through the Microsoft Security Development Lifecycle because it's really instructive to both how to develop secure software, but also to how to integrate security concepts throughout an organization. So the first SDL practice, practice number 1, is core security training. This says that we need to train our project managers, our designers, our developers, our programmers, our QA folks, our user interface testing personnel on SDL foundational concepts, which include the importance of secure design, how to do threat modeling, what are secure coding best practices, how to do security testing, and best practices regarding privacy. So before any of these folks even touch a project, we train them on all of these various concepts. SDL practice 2, 3, and 4 relate to the requirements phase. starting with establishing security and privacy requirements. So right at the very beginning in the requirements phase, identifying the key security and privacy milestones and security deliverables. SDL Practice 3 is to create quality gates or bug bars. The quality gates and bug bars are defining the minimum number and level and severity of bugs that will be accepted. So here we are defining the minimum acceptable levels of security and privacy. SDL Practice 4 is to perform a security and privacy risk assessment. So here we are way back in the requirements phase, nothing's been developed yet, but we're performing security and privacy risk assessments to determine if there's a regulatory impact, the privacy impact, and to help identify what are going to be the appropriate threat models to utilize. In the design phase, which is our practices 5, 6, and 7, we're establishing design requirements and integrating the security and privacy requirements right then and there. SDL Practice 6 is attack surface analysis and reduction. So reducing the attack surface is our entry or extraction point, by disabling or restricting access to system services, by requiring input validation, by applying the principle of least privilege, and by employing layered defense. So defense in depth, least privilege, input validation, and disabling or restricting access to system services. In SDL Practice 7, this is where we're using our threat modeling. So we're identifying threat scenarios, determining risk, and establishing mitigation. Now what's fascinating is all of this, again, is still happening in the design phase. There hasn't been a lick of code written yet. As we're moving into the implementation phase, this is where SDL practices 8, 9, and 10 come in. So 8 is to use approved tools and versions, to use approved tools to enforce security practices. We're not going to allow our developers and programmers to use whatever code they want. We're going to have an approved list of tools to ensure that those tools match our security requirements and practices. And those tools are going to be kept up to date. We're going to deprecate unsafe functions, meaning analyze functions and APIs, and if they are determined to be unsafe, we're going to stop using them, we're going to back up, find an alternative, and replace them. SDL Practice 10 is to perform static analysis. So prior to code being compiled, there will be a code review that's done. Moving into the verification phase, practices 11, 12, and 13, and perform dynamic analysis, so runtime verification checks for memory corruption, for user privilege issues, or any other security problems. Fuzz testing, remember we talked about fuzzing earlier, which is deliberately introducing malformed or random data to reveal security issues. And do an attack surface review. So again, review the attack surface to identify if there's any new attack vectors that are related to design changes that may have taken place or implementation requirements. And then before moving further, ensuring that those attack surfaces are mitigated. Then we move into the release phase, which is practices 14, 15, and 16, creating an incident response plan. The assumption is that there may be an issue that has to be dealt with. So in this release phase, ensuring that there is an incident response plan, that there is a preparation for new threats related to the software, to identify emergency contacts, and to establish a security plan. Before release, conducting a final security review. So once again, examining the threat models, the tool outputs, and the performance against the quality gates and bug bars that were defined way back in the requirement stage. And then lastly, to certify, release, and archive. So to certify that security and privacy requirements were met, and to archive all permanent data. And then finally, in the response phase, being prepared to execute the incident response plan, meaning maintaining the plan and practicing the plan. So all of these components are part of the Microsoft Security Development Lifecycle as related to developing secure software. So software has been developed and it's been released. And now we've moved into sort of a post-release phase. Users, security researchers, we'll also refer to them as white hats, and those with bad intentions may identify software flaws that can be exploited. Now, there are a number of publishers that now offer what's known as a bug bounty, which are rewards for reporting vulnerabilities and not going public for a specified period of time. Now, those are reporting the vulnerabilities directly to the publisher, not to CERT, and to agreeing not to go public for a specified period of time. Reported software flaws. If the publisher notifies CERT, then reported software flaws are assigned to CVE. And then the CVEs are published in both the MITRE and the National Vulnerability Database. We took a look many lessons ago at the National Vulnerability Database. Those NVD entries include descriptions, severity, impact, complexity, the access vector, authentication requirements, as well as references to advisory solutions and tools. So being familiar with the National Vulnerability Database and with CVE entries are critical skills for a security professional. The publisher response to a security flaw that creates a security vulnerability is, or should be, to develop and distribute fixes known as updates or security patches. In an earlier lesson, we discussed security patch management. Full disclosure is when a publisher notifies users as soon as a vulnerability is confirmed, even if a patch is not yet available. You may recall that a zero-day threat is the potential exploit of a vulnerability for which a patch has not yet been released. Zero-day attacks occur during the window that exists between when a vulnerability is identified and when a patch has been released. That's a very critical time, and we talked earlier about a response and mitigation plan that an organization may need to put in place during that window. And then we get to end of life. So the end of life date is when software is no longer supported by the publisher, including features, functionality, and security updates. Publishers generally post their end of life policies and provide ample notice, but they always seem to still be a surprise to consumers. So for example, last year Microsoft did an end of life for Windows XP. Still, many organizations were caught off guard and were not ready to upgrade their desktop operating systems. End of life is a particularly vulnerable time if organizations continue to use unprotected operating systems and applications. So end of life brings us to end of lesson. So let's do a lesson 8.1 review. We looked at the traditional software development lifecycle. We looked at the importance of secure software. We walked through the Microsoft Security Development Lifecycle, or SDL, all the SDL phases. We discussed post-release maintenance, security updates, and end-of-life retirement. So let's go through our lesson 8.1 terms, starting with SDLC. SDLC is our software development lifecycle, and that's the sequential process for software development. SDL was our security development lifecycle, that's developed by Microsoft. An attack surface is our entry or extraction point. A bug bounty is a payment in exchange for flaw identification. A security patch is a fix for flawed code. Full disclosure is immediate notification of a confirmed flaw, whether there's a patch available or not. A zero-day window is the time between flaw identification and a fix. So that brings us to our CISSP exam tips. Our 3 tips for this lesson are, number 1, security must be naturally integrated in all phases of the development lifecycle. Number 2, full disclosure gives organizations an opportunity to implement temporary or additional safeguards. And 3, layered controls help to mitigate the risk of a zero-day exploit. So thanks for joining me for this lesson. I look forward to seeing you in the next.